All right, guys. Today I'm going to go over this chapter test. This is our review. I put the questions up on the Google Classroom, so you know which ones you need to do. Use this to help you out if you need to figure out the answers. This is going to be classwork and homework, so it's worth double points, especially for people who want higher homework classwork grades. Something you should do. All right. So first, we got this jumbly mess of circles and lines, and we got to identify a couple of things. So what I like to do is use the letter first to figure out what it is. So a center, I need to find the center. So the centers are the middle of the circles, so that's either J or F. I see an F here, so number 4 is A, because that's a center. Next is a chord. A chord is a line inside the circle, and only inside the circle. So the line that I see that's inside the circle that's not in the past the middle is this line AE. But if you see, you have two line AEs, or EAs. You have EA and you have AE. Which one do you decide on is your chord? Remember, the line is only inside the circle. So it's only inside the circle. It must be with a line segment. Here, it has arrows on it. And because of the arrows, that means it goes past outside. Chord is only on the inside. So number 7 is my chord. So that's B. C, the radius. The radius here. So you need to find the radius. The radius is from the center to the edge. The center to the edge. So from here, the only ones I could see is FD or FA. And I see AF here. So AF or FA. So that's going to be number 2. Radius is 2. Let's see. And then what do we use? 2, 4, and 7. All right, next one, diameter. Diameter is a line that goes through the center. So through the center, it has to be AD. It's the only one on this picture. DA, AD, that's the diameter. So that's 5. Now secant. Secant is a line that goes through the circle. So it goes through the circle and in and out. So it goes all the way through, like an asteroid that goes through a planet right there. And the asteroid that actually goes through the planet inside the circle is this one, AE. But I have to keep going. So I need the one with the arrows. So this is number 1. So that's E. Next one, point of tangency. Point of tangency is a place where it's tangent. So where does it hit the circle? That could be G, that could be H, that could be E, that could be A. A line where the line hits the circle. It could be C also. And look at it here. C is the only one that fits. C is a point of tangent. So that's F. A common tangent. A common tangent is a tangent that's in common between two circles. So a line that's between two circles that touches two circles. So that could be line CG or that could be line GE. Both are common tangents in this case. CG is, or EG. So I see EG over here. So EG is this line over here. That's shared between the two circles. So that's a common tangent. And hey, I have leftover tangent. Tangent is a line that hits the circle once, and AB definitely hits the circle once. So that's H. You can pause the video, check your answers. Next one. How many common tangents of the given circle? Now, common tangents are tangents, like I said, that share between both circles. So how many ways can I draw a line that hits both circles? Since this circle is at the edge of the circle, I could put one right here to share between each other. So in this case, this has one common tangent. While over here, I could fit one here on top. I could do a little better. Here on bottom. But, and then your instinct might say, oh, it's 2, Mr. Tobel. But here we have another one that we could put where's my line? where it's right in the middle because it's hitting each other at one point. So you have 1, 2, 3 common tangents. 3 common tangents. So this one's 3. Either I'll tell you to draw them or I'll tell you to give me the number of them. So make sure you know how to do both. Okay, for this one, 11 and 12. 11, this is a right triangle. What we know about the sides of the right triangle, it follows this rule. A squared plus B squared equals C squared, the Pythagorean theorem. So the 2 legs will equal the hypotenuse. So 8 squared plus x squared equals 17 squared. So 64 plus x squared equals 289. Subtract 64 on both sides, x squared equals 225. Square root both sides, x equals 15. So this x over here should be 15. Again, you're just using the Pythagorean theorem. Next one, same concept. 26 squared is going to equal 24 squared plus x squared. 26 squared. 26 squared is 676. 24 squared is 576. Subtract down both sides. That'd be 100 equals x squared, square root both sides, 10 equals x. That is 10 equals 10. All right, 13 and 14, I will not give you, so you don't have to worry about that. Let's talk about 15 to 20. 15 to 20, AB and BC are diameters. AC and BD are diameters. So that right there tells you that should be a half a circle. Let's continue. Identify the given minor, major, and semicircles, find the arc. Okay. So identify what they are and then find the measurement. Okay. So I would just ask you to find the measurement, but just to tell you, a minor arc is less than 180. A major arc, you could guess, is greater than 180. And then a semi-arc or semicircle, my bad, is going to be equal 180. Kind of like a right triangle, acute, right, and obtuse, minor, semi, major. Same concept for arcs. Just twice the side because a circle could be 360 versus an angle just be 180. All right. Let's fill out all the things first. So I like filling out all the things first before I even start looking at this. I don't even look at this until I fill out my circle. See what I can fill out. Now you have to read the instructions. BD is the diameter. So BD is 70 plus blank plus 50 should equal 180. Because if BD is the diameter, that cuts the circle in half. So 70 plus 50 plus blank gives you 180. So I can subtract 70 plus 50 or 120. And then that's leave me with 60. So AE should be 60 degrees. Let's look at the other one. This is a semicircle. Again, AC because it's a diameter. So this one on the left, A to C, ABC I should say, is going to be 180. And this is 70. So 180 minus 70, so it'll give me 110. So this arc over here is 110 degrees. And over here, I have another semicircle. You can see it here. I got 60 plus 50 plus blank equals 180. So 180 minus 60 plus 50, which is 110, is 70. So this happens to be 70. And you could use this to your advantage. Look at this. You could have also used the fact that these two are vertical angles. So you know this one's 70, the other one's 70. Sometimes you don't notice that. I didn't notice that until I just got the answer. So it's okay. You should still be able to find everything doing the normal method. Now I filled out everything. Everything else is just simple addition that you can do with a calculator even. So let's do that. Let me turn off my phone. All right. AB, so A to B. So A to B, they give you that is 70. They also ask you for minor, major, or semicircle. I'm not going to ask that, but this will be a minor because it's less than 7. It's less than 180. Angle BC, angle B to C. So B to C over here is 110. We found that earlier. Degrees. ABC, so A passing B to C. So you got to get everything included in that one move. So A to C, that means 70 plus 110 is 180. You also know that because AC is a diameter, and diameters cut the circle in half. AE, from A to E, so here to here, that's simply 60. We found that earlier. CDE, so starting, let me erase this, starting from C, going past D to E. So C, going past D to E, 70 plus 50. 70 plus 50 is going to be 120. D, BDC, so starting at B, passing D, hitting C. So starting at B, passing D, so I gotta go this way, and hit C. So I gotta add 70 plus 60 plus 50 plus 70. That altogether should be 250 degrees. Somebody might mention, Mr. Tobel, since this over here is left over, can you do 360 minus 110? You could do that also, and you'll still get 250 because this is leftover stuff. So you could do what we call the negative space of it. Pause if you need the answers. Let's go to the next one. All right, couple rules about angles. First off, if you have the chord being the same, that means the arcs are the same. So if ED, arc ED, is 125 degrees, arc DF should also be 125 degrees. So that's your answer for this one. But let's say I asked you for this one, EF. Well, if you know this is 125 and this is 125, and you know a full circle is 360, you could do 360 minus what you know, which in this case is 250. So this would be 110. So this is 110. Please be clear. You don't need this answer for this question because it just asks for DF. That's 125. It only asks for DF. So that's where you can stop. But I could ask you that top part here. So you got to know to take all the pieces. All right, JML. So arc, JML. So I'm starting here, passing to ML. Here's another rule. If these lines are congruent and there's a perpendicular angle, that means all the arcs are congruent. So if this one's 60, this should be 60. Now, let's say, so your answer here is 60. But let's say I ask you, what is LK? Let's say if I ask you, what is LK or JK? JK, yeah. Well, MK is a diameter, and you could tell that for two reasons. There's a dot right here, so that means that's the center. Also, it's a line that hits both edges, so you know it's a diameter. Since it's a diameter, you got to remember, what does that do to the circle? That's right, cut it in half. So if it cuts this in half, that means this bottom part is 60 plus X equals 180. So 180 minus 60 equals 120. So this will be 120. This over here would also be 120. You could think of it for the same reason, or because these two pieces match, these two pieces also have to match. So this is 120. Again, give you a little bit more additional information because I could ask you for different parts of the circle. All right. This one, number 23. These are angle relationships in circles. When your angle is in the edge of the circle, not the center, but the edge of the circle, it is half the size as your arc. So if this is 100, it has to be half the size. So X here is 50. So your answer is 50 for this one. Here, since this D, look at the angle, goes from here to here, G to F. So it's talking about the arc here. So what would be the arc here if this is 80? Well, if it's half when you go inside, it's going to be double when you go outside. So this is 160. Now, let's carefully look. So this black squiggly line is 160 degrees. Let's look at this angle. Hold up, wait a minute. They have the same opening. Because it has the same opening, you can use the same number. So half of 160 ends up being 80. This is a concept. If they have the same opening, they're going to be the same measurement. So even if I drew my angle like, do it in a different color, even if I drew my angle like this, as long as the endpoints are the same, it's going to have the same measurement of angle. All right, so this one's pretty interesting. Let's look at this. All right. We're going to do one at a time. I'm going to explain the general rule, and then I'm going to tell you how to do all these. But here, this arc over here, this angle R represents this much of the arc. And then this angle P over here represents this much of the circle. Wait a second. This plus this adds up to a full circle. This angle plus this angle, the openings, add up to a full circle. But if you look carefully, just like this question, these are angles at the edge of the circle. So what does that mean for your quadrilateral? Your quadrilateral, the diagonals are supplementary. Write that down if you don't have it. Diagonals are supplementary for quadrilaterals in a circle, or it's called circumscribed in a circle. Since they're supplementary, that means they add up to 180. So 4x plus 5x equals 180. 9x equals 180. X equals 20, so that's 20. Next one, 7y plus 11y equals 180. 18y equals 180. Y equals 10. So x equals 20, y equals 10 in this one. Okay, this one. So remember, on the quadrilateral, diagonals, so opposite corners, are supplementary. That's true when they're in the circle. All right, here, if you have two edges and you don't have an angle in the center kind of looks like it's here, but you don't have an angle in the center, then it's the average of the two angles. So 130 plus 112 over 2. You can do the calculations on a calculator. Should be 121. Yeah, 121. So this one right here, x equals 121. Next one, you have a circle here, kind of looks like that eyeball situation. When you have the eyeball situation, it's not the average, so you don't add them together, you subtract them. But here's my issue. I know this bigger arc, which is 230, but I don't know what the smaller arc is. Well, you know what's the good news? Since this encapsulates this full circle, if this is 230, then this blue part has to be 360 minus 230. And it's going to be the leftover, which is 130. So this small arc is going to be what's left over in the circle, which is 130. We didn't do that. Oh, we didn't do that yet. Over 2. 230 minus 130 is 100. Over 2. So x equals 50. 28, 29, 30, and 31. We have not done 29. So we haven't done those. So we are not going to have that on the test. So that's it for the review. I got over all the answers. Use this video to your advantage. All right. Have a wonderful day.